So till now, we have seen the model architecture. Now, let me walk you through the IPYNB file, which I have actually implemented using Jupyter Notebook. So again, you can see here, this Jupyter Notebook is posted using uh, virtual machine in Google Cloud Platform. Uh, and this is the VM instance, which I have shown in my previous video. So let's open this file. So here you can see this code is basically the part 4 of the final project. Again, coming to the part 4, let's see what exactly the part 4 is. So part 4 is about build, train, test CNN on CPAR dataset. Okay. Uh, so this is the entire structure of the code. You can see the convolution layer 1, ReLU layer 1, and then pooling layer 1, convolution layer 2, ReLU layer 2, pooling layer 2, and then we have fully connected layer. So here you can see that at first we are importing the basic libraries like NumPy, Pandas, Matplotlib, and TensorFlow. So worth mentioning again, TensorFlow is the deep learning framework. We have Keras too, but as I mentioned previously, we are going to use only TensorFlow in the final project. And here we are just declaring the path of the uh, dataset, CIFAR dataset. Let me show the actual dataset too. So if we go to this folder and then open CIFAR 10 data, this is the data set that we are using. You can see that we have metadata and then 5 batches and then test data. Oh, okay. There is also FIMA diabetes. This might have come unfortunately. Sorry during the copying process. Please ignore it. So let's go to the code. Here we are loading. Here we are loading the uh, data. This is basically loading the data. You can see we have actually in this cell we have defined a function which is unpickle, and then here we are actually loading the data. You can see we have used that function unpickle, and then here we have basically printed the data, and then in this cell. Uh, Again, here also we are declaring a for loop and then using the unpickle function which we have declared in the previous cells, and we have used one hot encoder to convert the categorical variables or categorical images into the numbers. And here we are trying to display a sample image of the CIFAR dataset. You can see here. It is a bit blurred. And then in this cell, we are declaring a helper class that is CIFAR helper. And then you can see that in the CIFAR helper class, we are defining the init function, set up images function, and also the next batch. So all this we are doing, it's a kind of some pre-processing so that, before training, so that it will be easy during the training process. And here we are actually building the network. You can see here we have defined init weights function. It basically returns a TensorFlow variable that stores the weight for a filter. And then we have declared init bias function or the method, which basically takes bias shape as an input and returns TensorFlow variable that stores the bias terms. And then we have defined create convolution layer. Um, Here we are giving the filter shape and the filters, and then we are defining configuring a ReLU layer 2 in this cell, and we are here in this cell we are basically creating a pooling layer to that the convolution layer. And then finally, we are creating the fully connected convolution layer. And here we are creating the placeholders for input data and the labels. So basically, you can see that X is nothing but the input features and Y is uh, nothing but the two labels. So this is the output convolution layer one output. And then again, we are creating the pooling layer, convolution layer two, something similar to the convolution layer one, and then pooling layer two, and then pooling layer two output, and then finally fully connected layer again. So we are also adding a dropout layer to randomly drop a fraction of the outputs. And then finally, we are creating a fully connected layer. We are using soft cross entropy loss function. So this is basically to calculate the mean of the losses. And then we are using an optimizer to optimize the CNN model. And then finally, we are training and testing the model here. So here you can see that the number of steps is 5,000. And we are processing it in batch of 100. So we can see that. Let's go for the results. So initially, we can ignore those warnings. Initially, on step 0, we can see that the accuracy is 0.1011, that is 10% approximately. And then at step 100, we can see that it is 12%. It has increased, but eventually, if we go to the last step, it is 0.09, that is 9%. So we can see that the accuracy at first, it has started with 10%, increased to 12%, and then finally it has decreased to 9.99%. So that is how the code is working. So from this, we can see that it is a very poor performance. Uh, Good performance. So basically, we have compared this code with the another data set, that is CNN is also applied on another data set, that is MNIST data set. So in that data set, again, it is implemented in assignment 4. And then over there also we have trained the CNN model using 3,000 and 5,000 steps. It basically contains 70,000 grayscale images of digits 0 to 9 with a pixel of 28 into 28. So, and that model has two convolution layers, two ReLU layers, which is quite sufficient for the training purpose because it is a simple data set, again, grayscale images. But the current CIFAR data set, it has color images. It is more complex. We have more classes too. So we can see that from here, the MNIST accuracy is 95.58%, which is a good accuracy. Whereas for the CIFAR data set, the accuracy 9.98, which we have seen right now. So um, from this, we can say that this is because of the CNN is too shallow in the current uh, architecture. It requires a deeper network for future interaction. We have to add more layers, and also we have to avoid the potential overfitting, so no dropout. And again, the filter size is small. We have to increase the filter size also. So this is basically the part 5 of the project. Nothing but identifying performance issues or the performance comparison. So here you can see the table basically compares the MNIST accuracy and CIFAR accuracy. I mean CNN on MNIST and CNN on CIFAR accuracy. So initially it is 0.09 for the MNIST and 0.09, and it kept on increasing to 0.87 at 700 steps. But whereas uh, for CIFAR it is 0.1, which is not that significant. So basically, we have compared. I have compared the 50 steps taken from that MNIST accuracy, MNIST and CIFAR course, and this is the so here you can see that I have copied to a separate document which contains still last step. This is nothing but MNIST, and then also I have copied to a separate document. This is till last step. So this is CIFAR, so 0.09, which we have seen right now. So again, uh, this is about redesigning the CNN model. Now, why we are redesigning? Because our accuracy is very low. So we want to redesign. The redesign model has four convolution neural layers instead of two. And there are also increased filters, which is of 3 by 3 size for better feature extraction. We have also added a dropout layer, added after first convolution layer to reduce the overfitting. And again, maximum pooling is something we have introduced into it. So coming to the training part, I would say the same CFAR data set, the hyperparameters tune, you can see the batch size is 100, the learning rate is 0.001, and steps is 5,000. So for this redesigned model, we have achieved a higher accuracy of 71.7%, which is a significant improvement. So from 9.99% to making some changes, we have got it to 71.7%. So that is a very good change, we can say. Again, all this is contributed to the increased filter size, increased layers, so that when the convolution neural network is deeper, it could able to extract the features more effectively. So this is nothing but part six of the project. Part six of the project. Now let me go through the code for the code for the part six. So this is a part six code you can see. So again, almost the same code, but just that we are making some changes here. So we are again loading the same data, everything is same, but we are adding more convolution layers. Here you can see we have added more convolution layers than the previous architecture, and the size is also increased. So because of these deeper layers, uh, let's go through the training part. Here you can see that the steps is 5,000 and the batch size is 100, pretty much the same as the previous architecture. And you can see that the accuracy has started with 0.1 and eventually it has grown to 0.7, that is 71%. So which is a significant improvement. Again, this is a part 6 you can see, and part uh, 4 if we see it is 0.09, 0.09 versus 0.09 versus 0.71. So we can see that there is a significant improvement. Now, again, once again, comparing the accuracy and conclusion is that initial model it has 9.99% and the improved architecture has 71.7%. Again, this can be because of adding more convolution layers and dropout improved performance. And key takeaways is that CNN depth is crucial for complex data set. As the complexity of the data sets increases, we have to increase the depth of the CNN architecture also so that it can learn the in-depth patterns. So again, regularization techniques like dropout help prevent overfitting, and understanding data set is very important because that helps in designing our effective models. So let us go through the document, the report part. So this is the obtained CIFAR-10 dataset part 3, which we have done already. And here, build, train, test CNN on CIFAR-10 dataset. This is part 4. This is basically the configuration details. Um, and compare, that is part 5, compare convolution neural networks performance. This is a part 5. Here we have created a table to understand it better. And then part 6 is about how we can improve the initial model. So basically what changes we have included in the initial architecture so that the performance gets improved. Again, the same screenshot 0.7, 1 accuracy. Again, part 7 is about writing the project report. Uh, I have included the project overview, details of parts 4, 5, and 6 because these are the main parts. I have included the conclusions also, part 6 conclusions. And so these are the different files I'm submitting. as part of my final project. And then the one that is yet to be done is final presentation videos, which I'm doing currently. So yeah, this will be the end of the recording. Thank you so much.